you can see it's getting pretty dark over here. I'll just point it towards the screen. Okay, so this thing over here is an accelerometer, and I have fixed it over an hand gloves. This hand gloves is having an Arduino similar to this thing, this piece of microcontroller that's very much like open source, and you can very easily get it and program it. That's basically made for artists. I'm not a hardcore programmer though. So I fixed it. You can see this is the portion of Arduino. I know it's dark, can't help it, the room is a little bit gloomy. So anyways, so I fixed this Arduino over to this hand glove with two pieces of velcros, that straps, so that you can easily detach it. And over to that I have made a shield. The attachments fixed on Arduinos are generally called shields. So I have fixed a shield over to which there I have fixed an accelerometer. Now what accelerometer does is basically calculates the acceleration due to gravity in three axes, x, y and z. So, and it takes ADC values. We just need to feed these x, y, z values to the analog inputs, and there is the degrees come, the measurements come in radians. We need to transform it into degrees, and we read the degree values and put it in threshold. Like if the x-axis varies from this to this, then do this function. If the x-axis varies from this to this, then do another function. So it's as simple as that. Now what another thing we did is, this is a keyboard, the circuit board inside a keyboard. When you open up a keyboard, you will basically see something like this, a transparent sheet of two pieces like this one. So actually what happens is, when you press a key, these 2 points get in contact and yields that eventual value of the letter or digit, whatever you want. So basically what happens is, I have made a small sketch over here. As we have seen that this thing have two layers, just like two contact switches. They have two layers, and all these combinations are divided into matrix, like into columns and rows. Alright, now say same row and a different column value will yield something, say a digit like a letter like W. The same row and another column will yield something different. So these different combinations forms all the functions of a keyboard, like starting from your A to Z, then tab and caps lock and shift and control and all the function keys. So these things are formed by this varieties of combinations. Now my keyboard that I opened up have a circuit. This, as you can see, this piece, they have two layers, right? Now one layer controls all the combinations for the upper layer contacts, and the bottom layer similarly have all the combinations for the bottom layer. So what happens is, they have divided this whole thing into rows and columns, and they have fixed this, take this into this kind of contacts. They are actually aluminum contacts because it's a very cheap keyboard. Now what eventually I have experimented and I have seen is, when you select a specific combination of a row member and a column member, you can yield that particular value without this sheet, plastic sheet. So what I have done basically here, I have seen what are the keys, alphabets they use for the game, and Actually, the games are very flexible. You can change the key values, right? You can use W in place of A. You can use any keys. You can actually modify that, so that hardly matters. I have sorted out few combinations from the keyboard here, soldered some wires and extended them to some headers, and I have actually shorted them through some transistors. Actually, you can see here some transistor switches I have made, some transistor switches that I have made. Now I give signals